Okay, so the purpose of this task was to find a quadratic equation that fits your data. This is what your data might look like. That was your wing length. This is the average time of the drop. Okay, so if you graph just your wing length versus your average time and you put in a trend line, this is what it looks like. And that's the trend line that Excel will give you and an R-squared value. If you go to something like Wolfram Alpha calculator, you can put in your three equations to find your A, B, and C from the quadratic formula, A x squared plus bx plus c, and it will solve it for you. It'll give you the A, B, C. Now, you would have done that by hand, but that's just a first check that your equation is right. Okay, so what we want is we want to put your equation on there to compare them visually as it is. Now you can see I've already typed it in here. I'm going to type it in again just to show you how to do it. But basically what we're after is this, the y equals ax squared plus bx plus c. And we used an online calculator to make sure that our a, b, and c were correct. So just move that up there so that you can see what I'm typing, a, b, c. All right, so I've got the a, b, c. The x is my wing length, and I'm trying to determine average time based on the equation that I've developed. Now you can see it all typed in up here, and I'm just going to retype it in to show you what it looks like. So every equation starts with an equal, and the first one is ax squared. So the a is negative. I'm reading it down here. So negative 0.0574167. And then what I'm going to do is multiply that by x. So I'm just clicking there so I can drag this formula down, and I want that squared. So the little hat, that's shift 6 and squared. Then it's going to be plus bx. So here's my b here. So 0.781583 times and x again. And then plus c, but you can see my c is a minus. So I'm just going to go straight to minus 0.612187. And that gives me this answer here. Now, you can see it's gone down to the second line, and all those numbers are in there. If you pause the video, you'll see that. But on yours, those numbers wouldn't be there. So what you're going to do is, if we just get rid of this, you go up here, see how my mouse is changing from a big fat plus to a skinny plus. Click, drag, and it's going to calculate all of these values for you. All right, so now let's graph that. So you can see down here, we've already got a graph of the dots and Excel's trend line. But how do we put our equation on? So click, here we want these dots. If I hold control, I think it's control on the Mac, I have to play with that, and click over here, I can get these. That will give me the dots. This will give me another bunch of dots for my equation. So I'm going to come up here, I'm going to go insert. It's a scatter plot that I want, and I do want just the dots. So here's my graph. Now, this one here, the orange dots, that's my equation. So I actually want that to be a line. That's what I've generated. That's what I think is a good equation for the dots. So if I click on one dot and they're all highlighted, see how they're all highlighted, and then double click, add trend line. It's a polynomial, quadratic, and see how perfect it is? That's because I generated all those dots from my equation. Of course, they all fit on a line. The R squared value would be 1. I want to display the equation on the chart purely because it looks good in my assignment. Okay, and then I can come back here and I can play around with it. I want this one to be a solid line. I'm in the wrong one. Of course I am. So come back, grab this one. See, now it's gone orange. So I want it to be a solid line. I might make it a little bit more transparent so that I can see through it when I'm comparing. Okay, and you can see that's my equation. This is now missing just the trend lines. If I come back up here and click on the blue dots, I can get Excel to add a trend line. This is the one you see below. Again, it's a straight, it's linear at the moment, but I want polynomial quadratic, so degree 2. And this one I want not only the equation, but also the R squared value to tell me how good that equation fits that line. Now, that's looking much better. Obviously, things aren't labeled yet. You can do that. But remember, we're talking about all of this wasted space here. We really want to see how close are these blue points to these lines. Now, for the trend line, maybe not any of them, but for our line, 3 of them should be on it. I used the 3.5, the 7.5, and the 9.5. So all those points are actually on the line because I used them to generate that equation. So we just want to clean this up, make it look a little better. If we come down here and you can see that change, if we double click on that, we get this one up and we can change where the units start. We can add in other lines, major and minor lines. But let's not start at 0. The first point is at 2.5, so we could start at 2. That stretches it out a bit, gives us a better look at it. Again, same, like this bit of wasted white down here. If we could stretch it out again, give us a better look at it. So we could pretty much start this one at maybe 0.8. So if we come over here and we're clicking there and double clicking, it's telling us now that we're going from 0 to 2.5. So we could start this one at maybe 0.8, just have a look at that. All right, so now you have it. You can actually compare visually the points to Excel's trend line, the points to your equation that you developed. You could do the same thing with several different equations you developed using different combinations of 3 points, visually looking at them all. You can also here, because you've got the 2 different equations on there, compare the A values. They're fairly close, 519, 574, 726, 7816, 0.4, 0.6. So you can do a comparison of your A, B, and C values as well as that visual comparison. And don't forget, we could have the residuals comparison as a data table as well.